Today we're going to work on leetcode 1044, the longest duplicate substring. So this question asks to find all duplicated substrings, whichever is the longest one in a given string. So there are some examples we can take a look. So for the first example, the input is banana, and there are multiple repeated substrings. For example, A, and repeats A again, and repeats A again, and AN repeats AN, and repeats, and NA repeats again here. And of course, ANA is the longest one, which repeats. So ANA and ANA repeats. So we output ANA. And for the second example, because there's no repeated substrings, so we just output empty. So we can take a look at the length of this given string. This is 3 times 10 to the 4th. So this means our algorithm should be like linear or like n log n. So we cannot use like the brute force method to do the comparison. Okay, so what we are doing here is to we can, for given substring, we can use some hashing method to manually hash this substring. And if and I think it's very rarely to have conflicts, especially given the input is so long. So we'll first try to implement it naively. If we do see some conflicts, we can do the for each string with the same value with the same hash value, we can provide like a linked list or etc. Similar data structure to handle the conflict. But I highly suspect there will be any conflict, given this string length is so small like this. So what we will do is we will define some functions that can help us to easily retrieve the hash value. So we have like, let's use unsigned int, and we make it 64 bits so that we can reduce the possibility of conflict. We say m, this should be a prime number. Usually we just say it's 1337. So some other choices, it should be prime number. Another choice is 37, 131, 13331, and of course 13337. All of them are possible choices, and usually there's very little possibility to have conflicts. So then we have some input. So this one is to record the hash, and for this one, we will calculate p to the pi equals m to the ice. So okay, so then we will first pre-calculate all the hash values given this string. I equals 0 and I less than size of this string. If I equals 0, then we say hi equals si and pi equals 1. Otherwise, hi equals hi minus 1 times m plus the current value of si, and pi equals pi minus 1 times m. Okay, so those values are pre-calculated. Of course, we need to initialize h and p. Okay, now Suppose we have a function like this one. This is to check, given a string and given a length, we say that k, if there is a duplicate of length k, check if there is a duplication of length equals k in the given string s. So suppose we have this function, and we will notice that this function is, for example, if given k, this function is true, then for any number that is smaller than k, this function will be true. This means we can use binary search to find the position that k is true, but with k plus 1 it is false. Then we will just return we will know that k is the longest possible length for the duplication of string. Then of course this question asks us to output the string, so we add one more input parameter here as the output. Okay. Then we do the binary search. So the left side is 1, and the right side should be the length of this string. And we just use the binary search template. Middle equals L plus R divided by 2. So if we say check M, and we should give a string for output. If this is true, then it means S can be moved to the position of M. So S will never be less than M. So L can be M. Otherwise, R should be M minus 1, because R, if this function is false, then our output should be less than M. So R can be put at M minus 1. Then I think we are done after this, so we just return res. Then we will implement this check function. So for this function, we use an unordered set to record all the hash value we already visited, and we add the first hash value inside this this set. The first one should be hk minus 1, right? Because our k will be always greater or equal to 1, so k minus 1 should be okay. And for I equals k, I less than size, we can calculate the current hash value. Hash equals hash value is hk minus hi minus hi minus k, because these values have been multiplied by pk, so we will multiply them and subtract them from hi. So this is the current hash value. We don't need to consider anything about overflow because this is unsigned. It will automatically handle that for us. And we will check if this hash value is inside st, then it means we found a duplication, right? We found a duplication. If there's a duplication, then res should be equal to I minus k plus 1, and the length is k. And we just return true. Otherwise, we will return false. Yeah, let's try. Oh, there should be dereference. Oh yeah. Notice here we are using L less than R, and we put M equal to L, so this should be +1 here. And let's try again. So the answer is not correct, right? So there's nothing output. There's no output. Let's see what's the problem. So we'll read again this code. We have M and H and P, and P means Pi equals K to the M to the ice, right? And we have the longest duplicate substring function, and we first initialize H and P. Then if I equals 0, H0 is S0, and P0 equals to 1. And then for each HI, it's the previous value times the prime number, then plus the current value in S. And for P, it's the previous value of P times M. So this means P times have a multiplication by M for I times. Then we have the output string. We use binary search. Whenever L less than R, we first calculate the middle value, and then we check. If it's true, it means L should be at least M, so we make L equals to M. Otherwise, R should be M minus 1. And here is the implement of check function. We have input and output, RES. And we have another set to record all the value. Oh, I think we didn't put it inside this another set. Okay, so for case 1 and case 2, it's passed, but for case 3, we have some issue. I think the issue is here. So remember, for example, here our input L is 1 and R is 2. So first we get 1 plus 2 plus 1, so M equals 2 at the beginning. Then we did a check and it returns false. Then we update R to M minus 1. So R is 1 now. So then this while loop will break. We didn't do another check. So what we need to do is we need to do this check once again whenever we are outside, because we need the value for the RES. If we do it like this way, we should be able to pass. Okay, it passed. Then we make a submit. Okay, then it's all passed. Then we will try some other number. Actually, let's say if it's 31, will that work? No, 31 is not working. How about 37? Yeah, 37 works, right? 37 works. 131. I think it should also work. Yeah, it also works. So how about 13331? Oh, it's also, I remember that 1997 is also a prime number. Let's try. Okay. Yeah, it seems interesting, right? So if you have a quite large prime number, no matter which one you choose, you will have very little possibilities to have a conflict. Okay, and that's it. Thank you very much, and see you next time.